To unmute your line, press *6 or #6. To unmute your line, press *6 or #6.
Okay, Jack, do you want to get started?
Yeah, how many people do you have on? More or less.
I don't know, at least 20.
Okay, all right, let's get going then. Are we on?
Yes, you're all ready.
Oh, okay. Good morning, folks. My name is Zach Appel. I'm with the Clean Energy Manufacturing Center, and welcome to our October webinar on clean energy manufacturing issues. If you've joined us before, I think you know what we're about. If you're new to these webinars, the Clean Energy Manufacturing Center is an initiative of the BlueGreen Alliance Foundation, and our goal is to increase domestic suppliers in a number of clean energy sectors, and we essentially work with companies and communities to develop strategies and provide educational opportunities for companies that want to get into the supply chain. We also provide a number of webinars. We've had a monthly webinar for the last year. This is one on energy efficiency, and we'll be hosting our last one for the year in November on offshore wind, giving you an update on that. And hopefully at some point later on in December, we'll be able to provide a schedule for 2014. This morning, as always, we have a number of great speakers to talk about energy efficiency. Jim Hader, who's one of our energy specialists at CEMC. Andre, and Jim is calling from Alberta, Canada. If we lose him, we're, again, dispersed all over the country. Andre is in Washington, D.C., and Simon is in Michigan. So I will turn it over to Jim and take it from there.
Great, Jock. Thank you very much. Can you hear me? Do I have this thing unmuted correctly?
Yep, we can hear you, Jim. Thanks. Yep.
Perfect. Okay, I just wanted to make sure I wasn't talking to myself here. So thanks everybody for joining in, and thank you for the introduction, Jock. So I'm going to talk a little bit about a project that I did in Montana that was an energy conservation effort that was a little bit different than a traditional technology-based energy project. And I want to describe it a little bit to you folks just to kind of get you thinking a little bit about the different ways that you can approach energy conservation. So on this first slide, this is a series of questions that I kind of throw out as a sort of an introductory slide to the entire discussion. And I would ask everybody to kind of answer to yourself, you know, how you would answer these questions about either your company or a company that you might work with. And the thing I wanted to bring out here is that industrial energy conservation is a different thing relative to other energy conservation efforts such as commercial energy conservation or residential home energy conservation as examples. Residential energy conservation, you know, most homes are very similar in the way that they use energy, as are most commercial facilities. Think of like a Home Depot or a Walmart. You know, each Walmart and each Home Depot uses energy in a fairly consistent way. But manufacturing and industry, companies have very unique ways in which they use their energy. Some of them use them as part of their cost of goods sold. Some of them have very, very large energy consumption sort of overhead type issues. But every company, even companies that are in the same sector, can use their energy very differently. So it's typically very hard to use a one-size-fits-all solution. And every company that I've ever worked with in energy conservation will answer these questions differently. You know, they all have a different responsible in charge for their energy conservation. Some companies tend to be very equipment-oriented. Others tend to have energy consumption that's more based on the way people use energy. Most companies will tell you that they've done several energy audits and have had varying success with them. So I kind of throw these questions out again to be sort of an introductory slide for all the speakers, but the focus is, the goal here when you start thinking about energy conservation, and Linda, if you'd advance to the next slide, what we're really trying to do is as consultants or as energy consumers, is to really move up the energy maturity curve, if you will. In the good old days, you might have thought of energy conservation or energy as just sort of a fixed cost. A lot of companies, most folks don't see that anymore, but in many cases, energy in the past was viewed as kind of like rent. You got the energy bill from the utility and you just paid it just like you would pay your lease payment or something along those lines. And the focus now is to really move up that learning curve to the point where you really focus on energy conservation in all aspects of your business operation in an effort to continually drive down the cost of energy for your company. Next slide, Linda. So along those lines, I worked on a project that I want to describe to you just a little bit again to get you thinking maybe a little bit out of the box. I worked on a project in the Pacific Northwest with our local utility, which is Northwestern Energy in Montana, a group called NEA, which is the Northwest Energy Efficiency Alliance, and then a consulting group called Internoc. And what this was, it was called Strategic Energy Management, and the goal for this particular project was to introduce the concept into the Northwest that had been done by some larger companies in the area, and the concept was moving energy conservation into a management structure, much along the lines of a safety program in a company or a quality management program within a company, and move it out of the context of just doing specific and individual projects. So next slide, please, Linda. Again, this project was about building an energy management system, not targeting specific energy conservation projects. And in general, an energy management system is an effort to kind of move past the project approach of energy conservation and really incorporate energy management into the culture of the company. Again, think quality, where companies have really evolved in the quality world to bring quality management into just the way that they do business. It's the same idea for energy here, where you're still doing energy projects, but you're doing it as a result of the management structure of the company. And the management structure of the company is really driving the goals of continued energy reduction. So next slide. Just as a general, for those of you that may or may not be really familiar with management systems, a management system is more of a framework of processes and procedures used to ensure that an organization can fulfill a given group of tasks. So for energy conservation, the tasks turn into are really the projects, whether it be a lighting retrofit or a pumping system retrofit or some other series of projects that's specific to a given company. But the management system built around that was the mechanism used to identify those projects, execute the projects, and then monitor the results of those projects. So again, and next slide, please, Linda. This management system structure that we worked on with our companies in Montana, if you think of energy management as this pyramid here, it incorporates all of the elements of what we tend to traditionally think of as energy management, things like plant assessments and specific projects, employee awareness, training, all those tools that are in that energy management collection. The energy management system was really just that group of that structure that allowed all of those tools to be used to the greatest effect in a company. Now, this particular project we called Strategic Energy Management. This is not the only system that's out there. There's lots of them that work very well. You'll hear terms like continuous energy improvement, industrial energy improvement, high-performance energy management. There's lots of acronyms and names for the way that you can structure a management system that works for you and your company. But in effect, they all have sort of the same end result, and that's, again, to formalize energy conservation in a company that makes sense for that company. The next, and then going up the pyramid right to the pinnacle, just as it would be for quality, there's also system standards out there that if a company becomes very involved in energy management, they can go out and look for a certification like an ISO 50001 energy management certification, or the U.S. Department of Energy has their Superior Energy Performance certification as well, which takes ISO 50001 to another level. But again, the focus on this project was really building the system that would eventually turn into a certification. So, at a very high level, next slide, Linda. At a very high level, the way that it works, it was a process that we worked with these companies. It took about a year, and it was an effort to integrate this management system into their company. And at a high level, the first phase of it was to first assess where the company was in their energy conservation efforts. You have to know where you're starting from in order to know where you want to get to. So we would spend some time assessing the company's energy management and energy conservation efforts to date. And then the planning phase was all about developing the action plan going forward to build this management structure into the company. Once the plan was developed and the goals were established, the implementation phase occurred, and that was where energy teams were developed within the company. Usually an energy champion was identified as someone who was really going to take this process and get it done, if you will. Energy goals were identified, and then the organizational communication and structure was built as to how the energy team met and at what regularity and so on. And every company that we worked with really did this in an individual level, that in a way that made sense for that particular company. And then at the final stage for us was to help them and assist them in sort of the monitoring and support along the way, so that they could see the results that they were experiencing and track them going forward. And the goal here was to build a management team and a management structure in the company that continued past the project. So we wanted this energy team to continue to meet after we were done, and sure enough, they all did, and they all continue to have success moving forward with their energy conservation efforts. Next slide, Linda. So some of the folks we worked with in Montana, they gave us some good results and some good feedback on this process. One quote that I really liked is, when we started this effort, I thought it was an energy program that looked like a quality program. Now I realize that it's called an energy program, but it's really a productivity program. What this is really getting to is that, and it's been my experience as well, that in many ways your energy bill can be a great stethoscope into the overall health and productivity of your company. As a specific example, I've done quite a bit of work. I've done a fair amount of work with pumping system projects for the U.S. Department of Energy, and the very easy way for me to find a pump that's misbehaving and one that's not operating at its most optimal point is to look at the maintenance records for that particular pump. It's also probably a pump that has a lot of maintenance, goes down a lot, and has other issues. So if you turn that around, you can use your energy conservation as in many ways to learn more about ways to improve the productivity and the overall health of your company. So, and that was this particular person's experience. Next slide, Linda. We also did some work for a large Western mining operation, and what they told me was, they said that individually we always paid a lot of attention to our energy consumption, but this energy management effort caused us to come together as a group and focus on energy savings that really saved the company money. And asked him to elaborate on that. What he mentioned was that they were in a really big, just physically, this was a very big operation, and the folks that worked in it were spread out throughout the company. And each of the individual groups within that company had their own energy conservation efforts that they were working on, but getting them all together into the conference room, if you will, and working on these together allowed them to really build solid efficiencies and learn from each other's experiences and leverage each other's strengths, so that the projects and such that they did had greater effect and just did more for their energy conservation efforts as a whole. So, next slide, Linda. This particular company was a smaller company that went through sort of some transformational efforts, and that energy management was a part of. And their quote is, as it says here, it helped us develop goals that were actually meaningful to the company. Again, when he elaborated on this, what he was saying was that through their energy management effort, they were able to identify a lot of very strong projects that really drove their energy bill down to the point where it affected their cost of goods sold. And it affected their cost of goods sold by about 10%. And that allowed them to price themselves differently in their market. That reduction in their cost of goods sold allowed them essentially to access new customers. And this particular company grew from about a 20-person company to about a 5-person company. So it was very impactful to them just in the way that it was able to, again, participate in that transformation of their company. So I thought that was a really good result that shows that energy conservation can really be a very effective way to not just reduce your energy bill, but really improve the health of your company in general. So again, this project that we did was done in Montana. We did it over a 2-year span with several different companies. All of them found it to be very successful. And again, it plays into the next speakers that we have speaking today, in that energy management within a company can really then better leverage some of the tools and resources that the folks that are speaking after me can offer. So with that, I'm going to turn it over to them and let them continue, and thank you very much.
Andre, we'll turn it over to you.
Hear me? I think I just unmuted myself.
I can hear you.
Okay, good.
I hope everybody else can.
I'll take it as a yes. Thank you to the BlueGreen Alliance for inviting me to speak. I'm going to give a quick overview of the Advanced Manufacturing Office, which is the office within the Department of Energy where I work. And then, Linda, if you can go to the next slide, actually, that would be helpful. And then also talk about the Better Plants Program and Better Plants Challenge, which are two initiatives that DOE has launched to work with manufacturers to help them improve their energy efficiency. And I'm glad Jim mentioned the Superior Energy Performance Program, because that is a complementary initiative to these two programs that I'm going to talk to, and I'll describe their relationship a little bit better further on in the presentation. Next slide, please. So DOE's Advanced Manufacturing Office is really focused on increasing competitiveness of the U.S. manufacturing sector, and we do this through basically 3 different ways. One is industrial efficiency for specific energy-intensive industries. So these are the really large energy-consuming subsectors of U.S. industry, so primary metals, commodity chemicals, glass, forest products, et cetera. We also look at broadly applicable industrial energy efficiency technologies and practices. So these are often focused on particular pieces of equipment that cut across different industrial sectors, so things like motors, efficient separations, combined heat and power. And then we also look for innovations that help push forward advanced energy technologies. And here you can kind of think about this in terms of life cycle energy impacts, where we are trying to help manufacturers produce materials and goods that can significantly lower energy consumption in the use phase of those products. So things like carbon fiber composites that are super lightweight and super strong, when those are substituted for steel in the automotive sector, for example, it can lead to significant fuel efficiency improvements. Next slide. And the mechanisms that we promote these activities, we have R&D projects. These are sort of the traditional role of our office, where we fund projects that are undertaken by universities, national labs, as well as private industry. And then what's a little bit more new is R&D facilities. These are user facilities where small manufacturers and others can come and gain access to tools and processes that they may not otherwise have had access to. So we do have a facility that we co-sponsored on additive manufacturing, and another one on carbon fiber technologies, which is located at Oak Ridge National Lab, as well as a few others that are under development. And then what I'm going to spend a little bit more time talking about is industrial technical assistance. And this is really focused more on what Jim spoke about, which is trying to close the gap within the industrial sector between the energy efficiency opportunity, which we know is quite large, and where industry is today. So I'll elaborate on that a little bit more on the next slide. So this is important because the opportunity really is quite large in the U.S. industrial sector. So the industry really has a huge energy bill. On an annual basis, manufacturers spend more than $200 billion each year to operate their plants. And we know that a lot of that energy is being wasted. According to a McKinsey study that was completed just a few years ago, there's a potential of $100 billion in investment opportunity in cost-effective energy efficiency technologies, so those that have positive returns over their lifespan. And if that opportunity was captured, it would result in annual energy savings of almost $50 billion by 2020. So big, big investment opportunity there. And our own data from plant assessments that we've conducted over the years shows that individual facilities can often save 15% or more in their annual energy bills through relatively simple projects that have payback periods of 3 years or less. So we think a lot of this opportunities can be captured fairly easily. On to the next slide, please. The Better Buildings, Better Plants program is designed to help industry capture these opportunities. It is a national voluntary industrial energy efficiency leadership initiative, and it was rolled out as part of the President's Better Buildings Initiative, which has a broad overarching goal of improving the energy efficiency of commercial and industrial buildings by 20% by 2020. Better Plants is the industrial component of that, and through this initiative, we ask companies to set long-term energy efficiency goals. It's usually 25% over 10 years, and then we provide technical assistance to help our partners meet those goals, and then national recognition for their leadership when they achieve the targets or when they achieve certain milestones on the way. We do offer two different opportunities for companies to work with us through Better Plants. One is what we call the broader-based program level. This is what has the most companies participating so far. And then we also established a challenge level for companies that really wanted to go above and beyond and be more open about not only their energy performance data, but also the processes and mechanisms they've put in place to achieve those targets. Next slide. We do believe that setting energy efficiency goals is very, very important, and the data does back this up. A study that came out earlier this year from Johnson Controls Institute for Building Efficiency found that companies that issued publicly stated energy reduction goals on average implemented 50% more efficiency and renewable measures than companies that did not set those goals. These same companies are also 2.7 times more likely to increase investments in energy efficiency over the next year than other companies, and they are also more likely to adopt energy management practices. And then also important, these companies are reporting that they are beginning to see benefits that go beyond just the immediate energy and cost savings, including increased brand value, property value, and other co-benefits. So they're starting to experience some of these intangible benefits that come from energy efficiency strategies and progress on energy efficiency. Anecdotally, I think we've seen that a lot of this is true among our partners. We've had several tell us that our primary points of contact are usually the energy managers, the corporate energy managers within these organizations that have been trying to move projects forward for many years. And what they've told us is that after they signed up to Better Plants and after they set this long-term energy efficiency goal, at that point they started to see the capital start to flow towards energy projects. And partially this is because when companies do sign up, we ask that they make a corporate commitment across their organization, and we ask that that commitment be signed by a CEO or senior executive. So they're publicly making this commitment, so it does make sense that they would start to put money behind the commitment to make sure that they do achieve the goal. Next slide, please. So far within Better Plants, we've grown this program. It's been up and running for about 3 years, back to 2010. Today, it consists of over 120 companies, some very, very large, the Dow Chemicals and Alcoas of the world, and some very, very small single plant operations with maybe 200 to 300 employees. We don't have a size limit or restriction on who can join. It's really open to anybody. And these 120 companies represent over 1,750 plants. So it's important to keep in mind that we ask for this corporate-wide commitment. So when a company joins up, they bring all of their manufacturing operations into the program. And this equates to about 8% of the total U.S. manufacturing energy footprint. So a relatively significant slice of the manufacturing sector is now involved in the program. The numbers have been pretty good in terms of the energy efficiency improvement. Over the 3 years, you can see that that rate of improvement has declined. So we'll be watching that pretty carefully to see how we do in the future. But it is important to note that each year we are above that 2.5% benchmark rate that we want to maintain in order to reach that long-term 25% over 10-year target. One thing I will say quickly about that 25% goal, this is a really ambitious energy efficiency target. Our data from the Energy Information Administration shows that the industrial sector in the U.S. is expected to improve its energy efficiency by about 1.2% per year on a business-as-usual basis. So going 2.5% per year is asking manufacturers to go about twice as fast on average as they would otherwise be expected to do. And then cumulatively, the energy savings over time, 190 trillion BTUs. In dollar terms, that's about $1 billion saved cumulatively on energy bills. Next slide, please. We do have really good geographic coverage through this initiative. These are the number of plants. So of those 123 partner companies, this is the geographic spread on where the plants are located. And if you take a careful look at this map, you'll see, not very surprising, that the concentration tends to be in those states that do have a traditional, really strong manufacturing sector, so Illinois, Ohio, Michigan, et cetera. However, California also, we do have a number of plants, as well as Texas. Next slide, please. Now, in terms of the benefits that we're able to provide companies, this is a leadership initiative, so we do make it a point of providing national recognition to the companies that sign up through simple measures such as web profiles that we build for the companies, recognition letters that we issue, and companies can take quotes from DOE leadership and use it in their own press materials. And then we do hold special events. This past September, we worked with the World Energy Engineering Congress to put on a nice event during one of their lunchtime sessions. And then, excuse me, my screen just went blank. We also offer technical assistance, including access to a technical account manager. This is an individual that does have expertise in energy efficiency and can help the company establish an energy intensity baseline. If the company already has one, there's always ways of refining and improving metrics. And then we also help the company think through potential energy savings opportunities. And then the account manager can do a really good job introducing the company to tools and resources that DOE as well as other organizations have put out there to help advance industrial energy efficiency. And then and one of the things that the technical account manager can do is introduce the company to the Superior Energy Performance Program that Jim mentioned. We do have a lot of our partners. So Better Plants is a corporate level commitment. SEP is focused more at the facility level. But SEP can be a really great engine to drive energy savings to help companies meet those corporate goals. So the account manager can help the company get started on superior energy performance. And then one feature of the program that is quite popular are these in-plant trainings. There's actually a shot. The photo on the right was taken from an in-plant training that we did at an ALCOA event. And what we do in these situations is that we send an energy expert out to a plant, spends about 3 to 4 days there, conducts an assessment of an energy use system, but more importantly really does focus on training the participants. And the participants come from that particular plant as well as plants from multiple other locations that are invited there by both DOE and the host facility. And then more and more, especially as we grow the program and we start to get really great coverage across different sectors, we are beginning to provide more opportunities for companies to network with one another so that we can encourage a kind of peer-to-peer sharing that we believe is really, really quite important. Next slide, please. So for those manufacturers that are in the audience, some of you might be wondering, how do you join? The process is quite simple. We have a partnership agreement form. It spells out sort of the expectations both of the partner as well as DOE. we do ask that companies have a senior executive sign the commitment, and then you just need to scan it and send it back to the Department of Energy. We are happy to provide you with a copy of this form. My colleague, Joseph Hughes, who is on the line today, his email address is listed there, and he leads our outreach efforts. You can also send a general inquiry to the Better Plants email address that's listed there as well. And then my contact information will be provided at the conclusion of this presentation. Next slide, please. I mentioned at the outset that we also launched what we call the Better Plants Challenge, which is a higher level partnership. A little bit of background, the Better Plants Challenge is the industrial component of the Better Buildings Challenge, which cuts across sectors and also cuts across the Department of Energy. So we do have commercial buildings and public institutions that participate in this as well. In fact, the umbrella term for this initiative is the Better Buildings Challenge. When we say it's a higher level partnership program, it does, the big benefit for companies that do move into the challenge is greater exposure and greater recognition. So the President of the United States launched this personally back in December of 2011, and he was joined by former President Clinton. The companies do also then agree to some more commitments in addition to the energy savings goal that they set. They share with us their strategies and approaches to achieving those targets. In particular, they describe to us one example of really exceptional energy savings that took place at a particular plant or building. And then they also share with us their corporate-wide approaches, particular business mechanisms they've put in place to try to accelerate energy efficiency, specific barriers that we've seen overcome through these models are finance barriers, training, getting staff and employees up to speed on energy efficiency, and then ways of ensuring senior management commitment to energy efficiency. Next slide, please. Today, the Better Buildings Challenge overall covers over 120 public, private, and nonprofit organizations. The split in terms of sectors is provided on the left-hand side. And collectively, these partners represent over 2 billion square feet of commercial and industrial space, over 300 manufacturing plants, and then we do have a set of financial allies that have committed to a certain amount of private capital to provide the energy efficiency marketplace. Next slide, please. And here's a quick look at the 13 manufacturers that have stepped up to the Better Plants Challenge. So again, I mentioned earlier that there's 123 total partners in the Better Plants program. These are the 13 that have taken on those additional commitments. So some big names, including Simplot, 3M, Briggs & Stratton, Nissan, GE, Ford. These companies have really been great to work with. And with that, that is really the close of my presentation. My contact information is here, as well as Joseph Hughes. And then for more information, please feel free to go to either of those websites that are provided below. Thank you.
Thank you. Is that me now, Linda?
Yep, so I am making you the presenter, and you can share your presentation.
Okay, thank you. My name is Simon Gidney. I'm calling for, I'm president of Axial Fans and Drives, and very privileged to be able to join this webinar. We are, a little bit of very brief information about who we are. We're a Massachusetts-based company. Our particular area of specialty is in the design and manufacture of energy-efficient motors and fans. We have additional offices in the UK and in China. Axial Fans and Drives is a division of EPIC Engineered Technologies. EPIC is located in New Bedford, Massachusetts, and has been in business in that area for 65 years.
Sure. Simon, are you going to share the presentation then? Or are you still working on that?
I'm sorry, I thought I was. Let me,
yep.
Can you hear me? If it's easier, you can do that. I thought I had done. I do apologize. Is it easier for you to present the slide?
I sure can. I sure can.
Okay.
I just... go ahead. We've got.
Okay, thank you. So we've got to there. So I do apologize for that. A little embarrassing when you're talking about emerging technology and you can't operate a PowerPoint, but apologies for that. We can go to the next slide, please, Linda. Obviously, as we've seen from the very fact that this webinar is taking place today, there's increasing governmental focus on power consumption and energy efficiency, which obviously is a very good thing because it provides information and it provides a focus on the savings that can be made. The particular areas that we operate in principally are in refrigeration applications and also in heating, ventilation, air conditioning. Energy Star has been a particularly active governmental body in the refrigeration sector. They've actually mandated in the commercial refrigeration sector that refrigeration units that bear the Energy Star label next year actually have to show a 20% reduction in their power consumption from this year. So, hello?
No. So,
can we move to the next slide, Linda? Another factor that's taking place as well is that major corporations, as we saw on the last slide that Andre shared with us, with a number of companies who've signed up to the Better Plants initiative, a lot of leading corporations now are taking this very seriously and are looking down through their supply chain to make sure that where possible, products that they're buying, components they're buying, manufacturing partners that they have are also focused on energy consumption. I've just taken one as an example here because we've worked with Coca-Cola with their 2020 vision. I've actually said to all of their manufacturers of vending machines and cooler systems that they're looking on the vending machine side to, while they're looking to double the number of vending machines they have out there globally, at the same time as they double that number, they're looking to actually reduce by 20% the total energy consumption of those units. So that's an extremely aggressive target. And I think it's symptomatic of the theme that Andre touched on in his presentation. If I could have the next slide, please. Just a very brief overview to give the participants on this webinar an idea of the product areas in which we're involved. Essentially, brushless DC and electronically commutated impellers, larger fans and fan units, axial fans, and then the motors themselves. Can we go to the next slide? I don't want to get overly boring here and send people to sleep, but effectively the energy saving as far as motors are concerned comes from increased efficiency of the motor. And the efficiency is effectively the ratio of the power that comes in to the motor as compared to the power that that motor generates. And historically, old style technology, shaded pole motors, permanent split capacitor motors, tend to have an efficiency rating of somewhere between 15 to 20%. Meaning if you've got, you're losing effectively 80% of the power that's coming in from the power supply is being lost in actually operating the motor. The newer technology, electronically commutated motors, which use commutation electronics as opposed to actual metallic brushes, they would have efficiency rates in the size that we're operating in more like 70%. So you're actually only 30% of the power that's coming in is being used to operate the motor. So clearly that's a very significant step change, which has a profound impact on the energy consumption if you're running a number of motors. I can't access it now, but for later, as you'll see, there's a link embedded in this presentation. It actually goes to a video on the home page of our website, which gives a side-by-side video demonstration of an old technology shaded pole motor sitting next to our EC Plus motor, both motors are fitted with the same size fan ring and same size impeller blade. They're both running at exactly the same speed, so they're both producing exactly the same airflow. The older technology motor is drawing 30 watts of power, whereas the EC Plus, our electronically commutated motor, is drawing under 7 watts of power. So, you know, as opposed to just listening to me and telling you that's what's happening, it's a very useful graphic demonstration. It runs for about 2 minutes. Could I have the next slide, please? The motor that's featured on the video that I've just referred to is our EC Plus motor. It's available 120 volt, 220 volt. And the interesting thing there is the flexible speed, because this is the other way in which motors can aid energy savings. Rather than simply running at one speed, so it's either on or off, modern technology motors now will have variable speeds, so that if the ambient temperature, for example, drops and the unit doesn't need to be running at the same speed, it can be dropped down to a lower speed, thus saving energy. A practical example of that would be in a supermarket, say, where at night you pull down the door on the front of the freezer. There's a contact switch at the bottom, and then it drops the motor down to idle speed. So it drops to 600 RPM as opposed to running, say, at 1600 RPM. And if you multiply that effect by a number of motors, you know, you can see some very significant savings. Next slide, please, Linda. That's just an example of some of the applications that particular motor goes into: vending machines, coolers, display units for food that you'd see in cafes, restaurants, etc., and stores. Next slide, please. The other motor we have goes into the ventilation sector. We call it the EXR motor. It's available in low voltage. Once again, the key issue here is the efficiency levels and the variable speed. And again, those are the benefits that you're gaining if you're using a motor of this nature. Out of interest, in the commercial refrigeration sector, as I'd indicated at the beginning, Energy Star is very aggressively putting in guidelines so that in order to reach your Energy Star ratings and carry that Energy Star label in refrigeration, they're very aggressively bringing down the power consumption that refrigeration units are showing. What's interesting on the ventilation side, and on ventilation I'm talking about exhaust fans, kitchen fans, bathroom fans, range hoods, it's not so aggressive. We had an interesting example where we replaced a motor and a range hood, the kind of thing you get above your cooker or your oven in your house. And the replacement of the old style motor with a new technology motor made a very dramatic energy saving. It in fact exceeded the Energy Star threshold by 600%. But what's interesting there is because the requirements that are coming out from Energy Star in that sector are much lower, there's far less of an incentive. There's certainly not a mandate for people to change, manufacturers to change, and there's far less of an incentive to change. So I think there seems to be a slower curve in the ventilation industry for switching to energy efficient motors than there is in refrigeration. Next slide, please, Linda. Again, just an illustration of what I'm talking about here, products going into exhaust fans or range hoods. And the next one, please. Motorized impellers, bigger fans, 133 millimeters up to 450 millimeters. These go into a whole range of things. They go into server racks. Actually, if we go to the next slide, I've got a couple of illustrations there. Server racks, air conditioning units, telecom switching stations. Once again, the benefit of these is that you can run them off 120 volt or 220 volt mains power, but they have electronics within them that switch that to internally to DC current, which gives you functionality. Speed control, for example, you can have them tied into a thermistor You can even have them, the cabinets in telecom switching cabinets, remotely accessed via the web. So if the ambient temperature in the cabinet is low, then a signal can be sent to actually step the speed of the impeller down. So once again, you're saving energy. The next one, please. Hello. Hello, Linda.
Yep, you're seeing the low energy axial fans. Are you not seeing that?
That's it. Sorry, I lost it on my screen. And then the last one, just to finish off here, is low energy axial fans. Axial fans, as I'm sure the participants on this will know, appear in all kinds of applications, anywhere where there's any electronics to be cooled. And this technology now that I've been talking about has spread. We have these available in low, in axial fans ranging from 60 millimeters by 60 millimeters up to 172 millimeters. Global voltage, so the same unit runs off anything from 100 volts up to 240 volts. The reason this is particularly interesting is that we did a recent exercise looking at a fan tray application, which was running 3 fans, 120 by 120 by 38 millimeters. When we substituted those conventional technology fans with 3 of the what we call AF fans, we actually dropped the reduction in power consumption per fan from 14 down to 6, sorry, from 21 down to 6. So on a 3-fan fan tray, it was delivering a reduction in power consumption of 42 watts. Now, you know, on applications where you're using multiple trays, it's evident, therefore, that by making a change as simple as replacing one fan for another fan, you can actually deliver some very significant savings in the energy that's being used in that application. And the next slide, please. That just gives our contact details. My contact details are on there, so if anybody wants to contact us, you know, please feel free to do so. That concludes my presentation.
Thank you so much to everybody. We now reach the portion where our speakers are available, Simon and Andre, for any questions. If you do want to verbally ask your question, if that's easier, you can sure hit #6 or *6. That will unmute your line. Otherwise, feel free to use the chat feature to submit your question, and we can, you know, ask any questions the audience has of our speaker lineup. Next month, so you do know we will be talking about the offshore wind industry, kind of an experience one of our MEP centers has had, getting that supply chain up and going, what's happening with one of these DOE projects, and what the supply chain ends up looking like. Do have a question here. I would love to know if there are any specific new small handheld gadgets that will be required of people coming out of these new developments.
Small new handheld gadgets.
Well, let me make sure. Simon, are you on, or Andre, are you unmuted?
I think I'm unmuted. Can you hear me?
Yep, and then, yep, Andre's unmuted now too, so.
I'm not sure. We use small handheld gadgets.
Yep.
Yeah, I can't think of anything at the moment. We're not operating at anything that small. So no. I mean, I know there are developments. There's a lot of research taking place and developments in solar power as far as handheld gadgets are concerned.
Anything as far as like monitoring these fans, a handheld gadget or something that helps monitor?
Oh no, very much so. We have certainly with our motors. We have a Bluetooth facility so that engineers can change the speed remotely. Also, with the larger fans, the motorized impellers that I know, will, for example, in telecom switching stations, sensors can be fitted to those, and you can have a control center in a different country if necessary, who's able to monitor the performance of those fans remotely via the web. Each unit has a separate URL, and you can then make adjustments to the speed of those fans depending upon changes, for example, in the ambient temperature in the cabinet. So yes, that technology is definitely available, and I think it's going to be a very interesting growth area going forward. We've had a similar request we were working on with changing tack completely, going from a telecom switching station to a machine that makes your smoothies in a fast food outlet. There are developments there with having sensors on the motor that will send a remote signal if extra torque is being required of the motor, because that's an early warning that the mixture is becoming too thick and the operator needs to shut it down and to wash it out. So that's an interesting question. The answer is yes, and I think it's going to become something that's more and more prevalent, Linda.
Thank you, Simon. Any other questions from the audience? Well, I wanted to thank you all very much. We will be emailing out a PDF of the slides so that you will have the contact information available. This webinar was recorded, so we will try to post the recording. If you have a colleague that didn't get a chance to view it and you want to make sure that they get a chance to see the information, you can look for that on our website within the week. Thank you so much for your time today, and join us next month, the day before Thanksgiving, for our last webinar of the 2013 year. Thank you.
Thank you.
Thank you.